Hi, here we are discussing interference analysis, and in this interference analysis, we consider the central point that is bright because S1O is equal to S2O and N is equal to 0. Let us consider a perpendicular line in the plane of the paper, and that is passing through O. This we can imagine as passing through y-axis. All the points on this line is equidistant from S1 and S2, so that a bright center fringe which is in a straight line we can observe on the interference screen. In order to determine the shape of the other fringes, we can just go through this consideration where a particular fringe would correspond to the locus of all the points with a constant value of S2p minus S1p. For all constant value of S2p minus S1p, the locus of all the points will give you a particular fringe. It depends on two conditions. Whenever this constant S2p minus S1p is an integral multiple of lambda, we would get a bright fringe. If it is an odd integral multiple of lambda by 2, we would get a dark fringe. And generally, the locus of the point P lying in the xy plane such that S2p minus S1p is a constant will give you a hyperbola. So this is a hyperbolic structure in general. Considering the distance between D and screen is very means D and D is very small, capital D is very small, and here we consider that one of the condition where distance between slits is very large compared to beta, so that fringes will be straight lines. In order to prove this, two examples are given. For D is equal to 0.005 millimeter and for D is equal to 0.25 millimeter, and for this we would get a fringe with hyperbolic nature, and for the second one, later one, we will get a fringe with means interference pattern of straight lines. So here we mean that as the D and beta, D is comparatively large to beta, we can say that this will happen. Hyperbolic nature will observe less in this second case, and will observe in the first case. Here just imagine for the first case, as we considered so far, is S from the source to slits S1 and S2, point source S1 and S2 are equidistances. Then from S to O and S2 to O are equidistance, and this SO is a straight line perpendicular to S1 S2. But in this case we change the source is slightly changed from its position S, so that we can say that S1 to S1 S dash and S2 S dash are changing its shape. So we just assume S dash QS makes an angle phi, then it would give you the fact that OQ O dash will be exactly in minus F angle. So if S dash changes into upper side, then O dash changes to lower side. So we can say that this path difference will be the same. So this is the nature of the interference pattern if there is a change in position of the source light. Here we imagine instead of point sources, we generally get a interference pattern with straight lines. but for more intense here than the previous one, for increased intensity, a pattern with increased intensities, we can just assume that if we make slits in the shape of regular rectangular shape, we will get a more intensity interference pattern. So in this pattern, it shows that the screen with the fringes shows you the straight line interference pattern in this case. In this figure also, the path difference for 1 lambda, 2 lambda, it shows maximum displacement intensity.